I'm Lluís Miñarro. I'm Senior Director of can tooling at Hyperion Materials Technologies.
How long have you worked in the can industry?
More than 28 years now.
Today, we're going to talk about the manufacturing process of carbide tooling. The goal of this technical discussion is have the audience understand in basic terms how the final product gets created. What type of materials exist in the tool room?
We have carbide, we have steels, we have coated steels, and we have ceramics. And out of all these materials, carbide is the most common. Carbide is present in the copper press, carbide is present in the body maker tooling, and sometimes it's present on the necking tools. But especially on body maker and copper, carbide is the main material.
Why is carbide so present?
Because carbide represents a good balance between toughness and hardness. It's a good balance between getting a good resistance and at the same time having a material that is not breaking.
Explain to me, what is carbide?
Carbide is a material manufactured by powder metallurgy. It's a material that you cannot melt. You are manufacturing by pressing and sintering.
I've seen this image from Hyperion many times, and we want to be able to understand how we get from this powder all the way to the finished carbide tool. Can you walk me through some of the early steps when we deal with developing the alloy?
Here in Barcelona, we have the R&D laboratory that develops carbide grades for whole Hyperion. The first thing you have to do is design the grade, design the material, design the grain size of the tungsten carbide we are going to use, what tungsten carbide, what hard face, what binder, how much binder. And then we, at our powder manufacturing plants, we are getting the different raw materials, and then we are mixing those materials following the composition of the alloy that we have designed, and then we spray dry this mix, and then we obtain what we call RTP, ready to press powder.
This image, this is RTP. This is ready to press powder, correct?
Exactly. That's the ready to press powder. So this ready to press powder is compacted. There are two technologies being used to manufacture can tooling. I will start with uniaxial pressing. One is used mainly for ironing dies, hydro dies, copper press tools. You are filling a cavity with powder, then the punches are going up and going down. So you press this powder with a controlled pressure, and then what you get is a green body. It's just compacted powder. The other technology, that is the cold isostatic pressing, it's the one used for very long parts. This one is the one used for the punches. With this technology, you are putting the powder inside a rubber mold. This rubber mold is closed and is going down to a bath of water that you put pressure of water up to 1500 bars of pressure. So we are filling the mold, we are compacting with the isostatically pressed, and then you get a green body that is a compacted part.
If you were to take with your hands and touch that compacted material, what would it feel like?
It's like chalk.
Like a stick of chalk on the whiteboard.
Yes, exactly. It's brittle. You can break it in your hand. You can chip it very easy. You have to be very careful. What happens next is what we call green machining. We machine with a CNC lathe what it would be the shape of a punch. This shape has to consider that the final size after sintering would be much smaller.
In the green machining, help me understand exactly what characteristics or what features of the punch you would machine.
The key issue here is that during the sintering process, since we have the shrinkage, you have to be very careful about how far you go on this green machining.
Let's say, for example, the goal is to make a one-piece punch, so it has an integrated nose. So in the green machining, are you machining the entire nose profile?
Yeah, but it's larger, slightly larger.
What about something like the step or the transition?
No, we leave it cylindrical. The step transition or even the lower transition is not machined because the accuracy required by the finished punch is so tight that you cannot achieve that after sintering. The sintering process is the transformation of what it was just compacted powder to become a metal. Those black spots here are the crystals of metal, normally cobalt or nickel, and those crystals melt because of the temperature. So that process is what is done during the sintering process. So you see that we have an increase in density with a reduction on volume because we have removed all the air that was in between this green body.
How much time does the sintering process take?
It can take 8 hours. Normally it's around this for the tooling, but depends on the mass of material you are sintering. When the mass of carbide is large, you need more time. How thick is the mass of carbide you are sintering? It's what is determining that.
Now we've gone through the sintering process. What happens next?
So here there is a very important quality control process that verifies the mechanical and magnetical properties of the carbide to make sure that the carbide has been properly sintered. And we run metrology verification to make sure that the dimensions we get are the ones we are expecting to get.
When you're talking about the characteristics of the material itself, how do you test it without destroying it?
For the punches, we don't destroy a punch to make the properties, but we are sintering together with the punches a small sample made out of the same material, pressed and sintered under the same conditions in the furnace, and then we verify the density, the hardness, the magnetic cobalt, the coercivity on this sample. And for when it's rings, if we manufacture 1,000 rings or if we press a large quantity, we may destroy a ring.
What happens next?
Then we grind the parts.
Can you explain to me in basic terms what is OD grinding, what is ID grinding?
Well, OD grinding is the grinding the OD of a punch. The outside of the punch, you have the step, the upper step, and you have the lower transition, and the position, the shape, the geometry are critical to make good cans, to achieve the lightweight cans everybody is looking for. That's on the punches. On the rings, it's about grinding the internal profile of an ironing die, giving this extremely smooth surface from the grinder, and making the internal profile of an ironing die where it has to be. The position of the land has to be in a certain location, and the angle, the inlet and the outside angle, must meet the angles required by the customer. And that's what is achieved by the internal grinding.
What makes Hyperion unique in the world of can tooling?
We are materials experts and we know about can making. We are not just a company making material. We are a hard and super hard materials company, but we know how the cans are made. So combining how the cans are made, what are the customer needing to make the cans, what they actually need, then we can adapt the materials we have to the customer needs. That's what makes Hyperion unique in the world of can making.
Is there anything new or noteworthy that Hyperion has to share with the can making world?
One of the grades we have introduced in the industry that is widely used, it's the lightweight grade for the punches. We introduced around 10 years ago. The purpose was increasing the wear resistance, but also reduce the weight. We have made a step beyond, and we are very close to present to the market an evolution of this lightweight grade that will go beyond the DC-18.
That sounds exciting. Always something new that you guys are working on. Well, again, I appreciate your time today and sharing all this information with us. So thank you very much, and we'll look forward to the next conversation.
Thank you, Kalvis. Thank you for giving us this opportunity. Thank you very much.